Welcome to 2.5 video lesson, Algebra 2, using linear models, and there are 4 boxes for this lesson. So box number 1 is explaining the idea of a scatter plot and correlation. So I want to talk about scatter plots first and then correlation second. So you'll notice I have 2 what are called scatter plots, and a scatter plot is just a representation of data comparing 2 quantities. So for the first part over here in this blue scatter plot, I'm comparing 2 things. And these are the variables that I'm comparing. I'm comparing the height of a runner with the weight of a runner. And a scatter plot is just individual data points. So each one of these represents a specific data point. And as you can kind of see that as the height of the runner increases, the weight of the runner increases because the data is kind of looking like it's going up like that from left to right. Okay, on the left hand or on the right hand side here, I'm comparing 2 variables. I'm comparing interest of a ride versus the wait time in minutes. So the interest of the ride goes down if the wait time is high, right? That's what this is saying. So this scatter plot is tending to move downward. So interest goes down as the wait time gets higher. Okay, so that is all a scatter plot is. It's just a representation of data, but comparing 2 quantities. And you want to make sure you mention the 2 quantities whenever you're talking about this stuff. If we talk about correlations here, all right, and I'm gonna give you a moment to copy this down. But a correlation, there are basically 6 of them, but we only have to be responsible for 4 of them. So there's something called a strong positive correlation, meaning that the data is basically telling me that it's going up from left to right and the data is close together. This is a moderate positive correlation. The reason is being, yes, the data is still going up from left to right, but the data is not as closely clustered together as a strong positive correlation. So that's the difference between these 2 right here. No correlation is just a random cluster of information. There's really it's not going up, it's not going down. So nothing we can really say about it. That'd be no correlation at all. A moderately negative correlation is the same as a moderate positive correlation, except the data is moving in a downward direction. So as we move from left to right, the data moves down. A strong negative correlation is similar to a moderate negative correlation, only with the respect that the data is more closely together versus a moderately negative correlation, right? So if the data is close together, it's going to be a strong. If it's going down from left to right, we say negative. If it's going up from left to right, we say positive. This one we don't really have to worry about too much, but I did want to put it in here. So this is curvilinear relationship. So it looks more like a quadratic relationship, but this is not going to be part of our curriculum, but I did want to put it in there. Okay, so I'll shrink this box down so you can see everything. The main idea from box number 1 is that you understand that a scatter plot is nothing more than a relationship of 2 sets of data, and a correlation is how that relationship looks. Is it close together? Is it not close together? Is it negative? Is it positive? Is there no correlation whatsoever? So that's the main idea from box 1. Okay, box number 2 is an example, and all I want you to do is make a scatter plot from the following table and then describe any correlation that we might see. Okay, so the table is called shoe sizes, and I'm comparing 2 sizes. I'm comparing the US shoe sizes to the European shoe sizes. The hardest part about making a scatter plot, I think, is just setting up your scale. So what you have to do is you have to look at the lowest value of one set of data and your highest value. So it's going to go from 1 to 11. That's considered, a range sort of for US sizes. So I'm going to go from 1 to 11 on that scale. And then European sizes, it goes from 31 to 44. So I have to somehow make sure I fit 31 and 44 into my scale here. I used 10, 20, 30, 40, and 50. Probably should have used something a little bit more from the 30s, but it's still close enough. If I'm just making a scatter plot, then all I want to do is get some kind of a comparison. So 1 is worth 31, so that's probably about there. 3 is worth 34, so that's probably right about there. Okay. 5 is worth 36. That's also really close. 7 is worth 39, so just below the 40. Okay. 9 is worth 41, so just above it. And then 11 is worth 44, so right above there. So I've just created a scatter plot here, and then it says describe the correlation that you would see. So a description that I could say is, as the US shoe sizes increase, the European shoe sizes increase. And so I would say that this is looking to me like a strong positive correlation. So I would say this is a strong positive correlation. Why do I say that? Because the data is closely clustered together. It's not looking something like this, where it's a little bit further apart. There, it's more closely together. So I would say a strong positive correlation for number 2. Box number 3 is all about trend lines. So there's a lot of information here, so let me walk you through what I did. So a trend line is just a line that approximates the relationship between the two variables. So I have some data. I have the year, and then I have the cost. And what this is the median home prices for, I think, a town in Florida. So in 1940, the median hometown was 23,100. In 1950, it was 40,100, and so on. So I have data that goes from 1940 all the way to 2000. And what I've done for you is I've already created a scatter plot in Desmos and then brought that into the lesson. And the reason I'm doing this is because I want to show you how to create a trend line using 2 sets of data. Okay. So the 2 sets of data that I'm going to choose to use here is I just picked this point over here, 1040, and then 60,105. Now the 10 represents years since 1940. So at 10 years, this would be 1950. So basically I'm choosing this data point here, and then I'm choosing this data point over here. So I'm choosing 2. So the reason it's 60 is because the year 2000 is 60 years past 1940. So if I take these 2 points over here, which are 10, 40, and the other point would be 60, 105, I can calculate the slope between them. The slope would have to be 105 minus 40 divided by 60 minus 10. So I can go ahead and create or get the slope just from these 2 points right here. 105 take away 40 is worth 65. So I have that. And then 60 take away 10 is worth 50. If I take 65 and divide 50, I get 1.3. So I could write an equation in slope or point slope form. So I could choose this one, for example. So I'd say y minus 40 is now equal to the slope, which is 1.3 times x minus 10. So this is a trend. This is the equation of a trend line. So if I were to connect these 2 points from here to here, this would be a trend line that would approximate the relationship between the 2 variables. So y minus 40 equals 1.3 times x minus 10. You could also use 60 and 105 or any other 2 sets of data. I chose these 2 because they were far apart and they were relatively close to the midline. So that's all a trend line really is. It's a line that approximates the relationship between the 2 variables, and you get it simply by using what we already know how to do, the slope formula, and then plugging in and getting point slope form. Okay, for this last one, I'm going to show you how to create how to use the calculator to find the line of best fit. So for this one, you will need your calculator. So if you need to go grab your calculator, go ahead and do that now. So what we have here is we have the year, and then we have the average cost for 1 gallon of gasoline. So in the year 1998, it was $2.65. In 2000, it was $2.98, and then so on. So what I'm going to do is I'm going to show you how to create the line of best fit in your calculator right now. So I'm going to clear this out. And the first thing we have to do is we need to enter this data into our calculator, and we do that underneath the stat button, and we hit stat, and then we hit edit, and then I have L1, L2, L3, and what these are lists. So I'm going to enter in the year since 1998 for L1, and then in L2 I'm going to do the average cost. So I'm going to do XB years since 1998. So at 1998 I'm going to have 0, so I push 0 and then push enter, and then I'm going to do 2, enter, and then 4, enter, and then 6, enter, and then 8, enter, and then 10, enter. So all of my data, this is going to be years since 1998, goes in L1. I'm going to move my cursor over to L2 and put in all the average cost for the cost of gasoline. So 2.65, enter, 2.89, enter, 3.00, enter, 3.01, enter, 3.2, enter, and then 3.77, enter. You want to make sure that all of your data match, meaning you have one X for every single Y, otherwise your calculator is going to get real mad at you. Once you have this data set into your calculator, you can go ahead and hit second quit, and that brings you back to a main screen. This does not delete your data, so don't worry about it. Okay, we want to now calculate a linear regression line or a line of best fit. And the way that we do that is we again go back to stat, and we move over to the folder that says calculate. And then the option that we want is option number 4, where it says linear regression AX plus B. So I'm going to go down to option number 4 and push enter. And it's going to give me linear regression of AX plus B. And it has now calculated the line of best fit. So this says Y equals AX plus B. So the A value is 0.093 and the B value is 2.61. So for an answer, I would have the line of best fit was that Y would equal, what was it? 0.093x, 0.093x plus 2.61. So this right here is the line that best approximates the data. And if we were to graph this data against this line would go right through it. And I will show you how to do more of that in class tomorrow.